In example 3, using a diagram to model distance between cities. There is a straight road leading from the town of Westboro to Agratown, 30 miles east and 10 miles north. Partway down this road, it junctions with a second road perpendicular to the first, leading to the town of Eastboro. If the town of Eastboro is located 20 miles directly east of the town of Westboro, how far is the road junction from Westboro? Now, in this particular problem, it is very helpful for you to draw a picture in this situation. So let's take a look at the figure 4. It would then be helpful to introduce a coordinate system, and while we could place the origin anywhere, placing it at Westboro seems convenient. And this puts Agratown at coordinates 30, 10, and Eastboro at 20, 0. So let's take a look at the problem again. So there is a straight road leading from town of Westboro to Agratown. So there's a straight road. Westboro goes straight to Agratown. Okay, and that's 30 miles east and 10 miles north. Now, partway down this road, it junctions with a second road, and that is perpendicular to the first road to the town of Eastboro, which is right here. Now, if the town of Eastboro is located 20 miles directly east of the town of Westboro, we need to figure out how far is the road junction from Westboro. So now that we have our picture, you can see that we started this at 0, 0, there's 20, 0, and there's 30, 10. So what we want to do is, using this point along the origin, we can find the slope of the line from Westboro to Agratown. So to find the slope, we take 10 minus 0 over 30 minus 0 to get 10 over 30, and m is equal to 1/3. So now we can write an equation to describe the road from Westboro to Agratown as a rate. So w of x is going to equal 1/3 x. Now in step 4, from this, we can determine the perpendicular road to Eastboro will have a slope of m is equal to -3. Because we know that it's perpendicular, it's going to be the negative reciprocal of 1/3, so therefore m is equal to -3. Because the town of Eastboro is at the point 20, 0, we can find the equation. So we know that we have the ordered pair 20, 0, and we know we have a slope of -3. So the output is going to be 0, and the value of x is going to be 20. Now we can solve for b. So -3 times 20 is -60. Adding 60 to both sides gives us b is equal to 60. So now we can write this equation. E of x, meaning Eastboro, is going to equal -3x plus 60. In step 5, we can now find the coordinates of the junction of the roads by finding the intersection of these lines. In order to find the intersection of these lines, we're going to set them equal to each other. So we're going to say E of x, W of x is going to equal E of x. So we're going to say 1/3 x is equal to -3x plus 60. And we're going to solve for x. So we're going to multiply both sides by 3. So we get x, which is equal to -9x plus 180. We add 9x to both sides, and so 10x is going to equal 180. Divide both sides by 10, and x is going to equal 18. Now we need to plug 18 back into the function to find out what the y value is going to be. So 1/3 times 18 gives us 6. So therefore, the roads intersect at the point 18, 6. But we want to find out what is the distance. So we have to use the distance formula to find the distance from Westboro to the junction. So the distance is equal to the square root of x2 minus x1 squared plus y squared minus y1 squared. So remember, we're starting at the origin of 0, 0, and we're going to the ordered pair of 18, 6. So we get the square root of 18 minus 0 squared plus 6 minus 0 squared. We get the square root of 360, which gives us approximately 18.974 miles. Now, one nice use of linear models is to take advantage of the fact that the graphs of these functions are lines. This means real-world applications discussing maps need linear functions to model the distances between reference points.